Let's look at one-sided limits with algebra, not based off of graphs, and we'll look at some piecewise functions as well in this lesson. One thing to remember with limits is if you can show the overall limit of a function exists, so the limit from both sides, then by default, the left and right sides must also approach that same value. So some of these limits, we're going to ignore the one-sided aspect of it, and we're going to treat it as a limit from both sides. And if we can show that the two-sided limit exists, then we know that the one-sided limit will exist as well. And that's exactly what we're going to do on these first couple of problems. So we have number 1, 3 is, we're approaching 3 from the left. However, I can just directly substitute 3 squared minus 7, and that will end up being 2. So in my mind, I was ignoring that little negative, and I just did the limit as x approaches 3. But because the limit as x approaches 3 exists, then I know that the left side must exist also. Can do the same thing on number 2 down here. If I plug in 5, you can do the arithmetic. It is indeterminate, 0 divided by 0. That means something should cancel. So I've got to figure out what level of algebra I need to do in order to cancel. And so my numerator, I can't really do anything with that. However, my denominator, I can factor out a 4x. That'll leave me with x minus 5. And I notice in the numerator and denominator, I have factors that are exact opposites, so I can cancel a 5 minus x with an x minus 5. Just remember that when you do cancel those, they are opposites, and there is a negative 1 left over. Now I can substitute directly in for x. So I'll plug in 5 for x. That'll be negative 1 over 4 times 5 is 20. And there is our answer for number 2. Okay, so let's move on and look at something a little bit more difficult. So here we have a piecewise function for x equals 2, and on the left side of 2, we have the line 2x minus 3. We have the quadratic for x is greater than 2. And if I'm looking at part A, it's x approaches 2 from the left. Now this time we cannot ignore that left side. We have to think about it right now, and we have to look up at this function, and where is the left side of 2? And that's going to be when x is less than 2. So x is less than or equal. So left side is up here. So now I'm going to say, well, I'm looking at 2x minus 3, so I'm going to direct substitute into 2x minus 3. I'll keep this color-coded. That'll be 2 times 2, so I'm substituting 2 in for that. And 2 times 2 minus 3 is 1. For the right side of 2, I've got to look up at my piecewise function and find where the right side is. And that would be when x's are greater than 2. So I'm looking at this bottom piece. And for the right side of x equals 2, I have the equation x squared plus 3. So that'll be 2 squared plus 3, 4 plus 3 is 7. And now I've shown that the left and the right sides are equal to 1 and 7 respectively. And this was not asked, but I can look at this and I can conclude that the limit as x approaches 2 of f of x, because left and right were different, I can say that limit does not exist. Okay, let's look at number 4. And we have quite the ugly function. We have this weird fraction for x is less than 3, x equals 3 is 5, and x greater than 3 is 2x plus 7. So here I'm looking for 3 from the left side, and so we want to find the left side of 3, and that is when x is less than 3. So the left side of x equals 3 is up here. And so I'm going to have to work this one out, and this one's not as easy as the previous one, so I'm going to rewrite the problem, and I'm going to substitute my function, x squared minus 9 over x squared minus 4x plus 3. And now when I substitute, 3 squared minus 9 is 0. X squared is 9 minus 4 times 3 is 12. So negative 3 plus 3 is 0. We have the indeterminate form. So now I'm going to do some algebra. And this is primed and ready for factoring. So when I factor this, x plus 3, x minus 3 in the numerator. In the denominator, x minus 3, x minus 1. I notice that I can cancel x minus 3's. And when I do that, I can now substitute 3 plus 3 is 6, 3 minus 1 is 2, 6 divided by 2 is 3, and we have our answer for the left-hand limit, or the limit as x approaches 3 from the left. Let's look at number 5. We want the limit as x approaches 1 of this function, and notice it does not specify one side or the other, and so that means we have to look at both sides. We have to look at both left and right. Now, the thing that a lot of people who are new to limits will want to do is they'll say, well, it's not asking for left or right, so when x is equal to 1, it's got to be 7. Except limits don't care what's happening at the x coordinate. Limits only care what's happening left and right. So we actually have to work out two limits here. I've got to think, what is the limit as x approaches 1 from the left? And then I'm going to have to find the limit as x approaches 1 from the right. And up here, my left side is up top, my right side is on the bottom. And so limit as x approaches 1 is going to be, or 1 from the left is 2 times 1 plus 3. And that gives me an answer of 5. So my left-hand limit is equal to 5. My right-hand limit is x squared plus 4. So I'll plug in 1 to that. So 1 squared plus 4 also is equal to 5. And now I can see that the limit as x approaches 1 from the left is equal to the limit as x approaches 1 from the right. So I may even write a conclusive statement here. The limit as x approaches 1 from the left is equal to f of x. F of x is equal to the limit as x approaches 1 from the right of f of x. And they both are equal to 5. Therefore, the limit as x approaches 1 overall of f of x is equal to 5. So there is your answer for that one. Let's move on. Number 6. This one's a piecewise, but a little bit different. This one doesn't say x is greater than or less than 9. It simply says x not equal to 9, and then the function is at 12 when x is equal to 9. So if I want to know the limit as x approaches 9, it does not specify one side or the other. So that means, again, we have to look at both sides of x equals 9. So I have to look up here this piecewise function, and where would I find the left and the right of x equals 9? And in this case, it's actually the same equation. If I'm on the left side or if I'm on the right side of 9, I am not equal to 9. So this top equation does represent both sides. And this is actually going to simplify the process because now I don't have to consider left and right independently. So both sides is up here. So the limit as x approaches 9 is going to be the same thing as the limit as x approaches 9 of the root of x minus 3, root of x, then minus 3, all over x minus 9. If you substitute, you would get 0 divided by 0. So I'm going to have to do some algebra here to cancel something, and I see a radical expression, so I am leaning towards conjugates. I will rationalize the numerator, root x plus 3 on top and bottom. And remember, when you rationalize, you only take the time to expand the conjugate pairs. So I'll have root x times root x is x, negative 3 times 3 is negative 9. We do not expand the denominator because I need to cancel that x minus 9 that is down there. So we'll leave the denominator intact. I can now divide out and cancel the x minus 9s. Leaves a 1 in the numerator, and now I substitute the 9, 1 over the square root of 9 as a weird none. I have some weird writing. Plus 3, and that ends up giving you an answer of 1, 6. I think I have one more. Oh, no, I don't. Okay, so that was all of them. So there are some limits of piecewise functions, one-sided limits using algebra, and hopefully that made some sense for you.